Okay, so here's a problem from chapter 11, and the problem asks you to expand x minus 3 to the fifth power. And they're not actually asking you to, multiply this out in terms of foiling and foiling and foiling again. What they're asking you to do is use the binomial theorem. Okay, so in our binomial theorem, if we're looking at this right here, the a in our theorem, and I'm not writing out the theorem because it's in your book. It's also in your notes, and it's really kind of confusing actually the way that it is written out. I think it's easier to just take you through the example. So a is negative 3, and that is this constant right here, including that sign, and then n is 5. Okay, and the way this goes is it's going to be we're going to take the combination of 5 things taken 0 at a time. That's starting here at this number. And then we have x to the fifth power, so x to the nth power. Okay, and then we're gonna ascend this number right here in our combination. So we're gonna do a 5, 1. That's a combination of 5 things taken 1 at a time. We're gonna descend this power on x, so this goes x to the fourth. And then we're gonna take our a and we're gonna move our a up in power. So this is going to be negative 3 to the first power. Notice that you have a power of 5 here, and between these two we have a power of 5 here, and that will continue to happen as we go down. So if we perpetuate this pattern, the next thing is going to be a combination of 5 things taken 2 at a time. Descend the power on x, so it goes x to the third. Ascend the power on negative 3, so it becomes negative 3 to the second power. And again, 3 and 2 gives us a power of 5. Okay, and then we have plus, this is going to be a combination of 5 things taken 3 at a time. Descend the power on x, so we go to an x squared. And then negative 3 to the third power. Okay, so that's ascending that power right there. Okay, and then take this combination again, move the power up, a combination of 5 taken 4 at a time, and then we have x and negative 3 to the fourth, and then a combination of 5 taken 5 at a time. Now there's no x because it's x to the 0 power essentially, which is 1, and we just have a negative 3 to the fifth power. Okay, so we just need to write all of this out now, and it's pretty long, but each of these combinations we can actually use Pascal's triangle in order to figure out. You can do the combinations on each of these, but you can actually just use Pascal's triangle to figure out what each of those numbers are. So Pascal's triangle looks like this. Let's see, I'll do it on a separate piece of paper, I guess. So Pascal's triangle, you start with a 1, and then you've got a 1 and a 1. And then what you start doing is you have 1s on the outsides, and you start adding these numbers together to get that number right there. Okay, so I would have a 1 on the outside, I'd add 1 to 2 to get 3, 2 and 1 to get a 3, and then a 1 on the outside. And then I have a 1 on the outside, add 1 and 3 to get 4, 3 and 3, 6, 3 and 1, 4, and then a 1 on the outside. And if we keep doing that, you're going to notice, this line right here, 1, 5, 10, 10, 5, and then 1. These are the numbers that are going to correspond to these combinations right here. Okay, so for instance, this one's going to be a 1, and this one's going to be, 5, 10, 10, 5, 1. So 1, 5, 10, 10, 5, and 1. Okay, so that's how we'll figure those out. And like I say, you can do the combination on them, but I think Pascal's is easier. All right, so what we're looking at now is we have a 1 right here times x to the fifth. So that takes care of that term. And then we have a 5 times x to the fourth times a negative 3 to the first power. So that's just negative 3. Then we have a 10 times x to the third, I'm right here, times negative 3 squared is 9. Okay, then we have another 10 times x squared times negative 27. That's negative 3 to the third is negative 27. Then we have plus 5, that's this 5, times x times negative 3 to the 4th is 81. And then we have 1 times negative 3 to the 5th is negative 243. Okay, and if we just multiply all of those out and just write it out, we have x to the 5th. We have a negative 15 x to the 4th. We have a positive 90 x cubed. We have a negative 270 x squared, a positive 405 x, and then a negative 243. Oops, negative 243. Okay. Okay, and that's it. That is that x minus 3 to the 5th expanded using the binomial theorem and Pascal's triangle.